Alright, these practice problems are pulled directly from your homework. So if you're actually watching the videos, here's your reward. Let's look at this first set of instructions. It says use the graph to determine the limit for each of the following. The limit as x approaches c, remember that positive means from the right, of f of x. And so in this particular example, it tells me that c is -2. So I'm looking here. If I look at this limit from the right, I see that it is approaching a y value of 2, so my answer here is 2. Going on to part B, the limit as x approaches c from the left. So if I follow this function from the left, when I get to c value of -2, the y value that I get to is also 2. And then it says the limit as x approaches c of f of x, I match my limit from the left and the right, mix that up from the right and the left, and so this limit is also 2. Now, this is not what the question asked, but as a little side note here, the function is actually defined at 3, and so if I found the function at -2, it'd be equal to 3, but the limit as x approaches -2 is 2. Because these do not match, that's my big indicator that this function is discontinuous. Okay. Again, not what the question asked, but a nice little side note there. Next question. Find the limit if it exists numerically, graphically, or analytically. Analytically, I'd have to be able to factor something or maybe multiply by the complex conjugate, or just the conjugate, but I really don't want to do that. Let's do it numerically. I could graph it, I could see what happens, but graphs can be misleading, so I really like to do things numerically. And so I'm approaching 4 from the left, which means that I need something a little bit smaller than 4. So I'm going to let x equal 3.99999, however many nines you want to carry out. And so in my calculator, if it says I can do it numerically, that definitely means I can do it in the calculator. I'm going to plug that number in for x. So I'm going to do the square root of 3.9999 minus 2 over 3.99999 minus 4. If I type all that into the calculator, I get this beautiful decimal. I get 0.25000153. And in front of all those zeros, I see a nice pretty 0.25, and so I think I can say that that limit is 1/4. Final answer. Next question. Find the x values, if any, for which f is not continuous. State whether or not the discontinuities are removable. If I can remove it, that means that I've got a hole. If I can't remove it, that means I have a vertical asymptote. And the way that you remove discontinuities is by canceling with something that's in the numerator. And so the first thing I always want to look for is, can I factor anything? And I see that, yeah, I can factor that denominator. It's a difference of squares. So I can say x plus 1, x minus 1. And things are discontinuous whenever the denominator is equal to 0. So if I look at the denominator, I can say that x equals -1 or x equals 1 would give me 0, and so those are my discontinuities. And the question is, are they removable? Well, there's nothing that I can cancel with that numerator, so these are not removable. And remember, not removable indicates that these are vertical asymptotes and not holes. All right, one more question. This one says to find the limit as x approaches infinity of this fraction. Now from the notes, what you need to look for is if the highest degree on top is bigger than the highest degree on the bottom, then you know you're going to approach infinity. If the degree on the bottom is bigger, then you're going to approach 0. But if your degrees are the same, like we are here, then your limit will be equal to the fraction of your leading coefficients. Those are the coefficients in front of those highest degrees. Now the reason I like this example is because I don't want you to be fooled by the order, right? We're very used to seeing the highest degree first and then our constants last. Don't let that fool you. No matter where it occurs, you're looking for your highest degrees and comparing those. And so back here I've got 10 over negative 4. That reduces to negative 5 over 2. And that would be my final answer.